Okay, this is a continuation of problem 8.2.17 from the study plan. And in the first video segment, we constructed the hypothesis test. Where the null hypothesis is the proportion is equal to 0.8, and the alternative hypothesis, the proportion was greater than 0.8, and we said that that's the claim. The test statistic was 1.41, and the significance level that we're supposed to assume is alpha equals 0.05. In the previous video, we found the p-value to be approximately 0.08. This is the probability of getting a test statistic, of getting a sample proportion that's at least as extreme as our test statistic, which is z equals 1.41. So the p-value of 0.08 is the probability of getting a sample proportion as at least as extreme as our test statistic 1.41. And if you look on the first diagram, because that proportion is larger than our significance level, if we look on this diagram, we see that our significance level was 0.05, and the p-value is greater than that significance level. So there's a greater probability of rejecting the null hypothesis, assuming the null hypothesis were true. So we do not have enough reason to reject the null hypothesis and support the claim. To reject the null hypothesis, we need to have a value of less than, the same or less than 0.05 as our proportion, because that would show that it would be extremely rare of getting a test statistic as least as extreme as 1.41 if the null hypothesis were true. Only when the p-value is low can the null hypothesis go. The p-value has to be lower than the significance level for the null hypothesis to go. Now, the critical value method is another method of hypothesis testing, and in the study plan question, they're asking for the critical value. We use these critical values to perform the critical value method of hypothesis testing. And with a critical value method, we are looking for the critical value. So we're looking for this critical value here, which is on the border of this red shaded critical region for the second diagram. We're looking for that critical value. And if our test statistic falls outside that critical region, then we cannot reject the null hypothesis. So this red shaded area with the critical value method is our given significance level, and we're looking for the critical value, which is the z-score, on the border of this critical region. And then we'll see if the test statistic falls within that critical region. So to find this z-score at the border of the critical region, which has an area of 0.05. The proportion under this normal curve is 0.05. Remember, we need to use table A2, and table A2 only gives areas to the left of z-scores. So to obtain the z-score, we have to find the area over here, and that is the total area, 100%, minus the area on the right, and that is 0.95. Now if you look at table A2, the closest value to 0.95 is 0.9505. And that corresponds to a z-score of 1.65. So that is our target z-score, 1.65. It's on the border of the critical region, so that's our critical value that we're looking for. Z equals 1.65. We only have one critical value because this is not a two-tailed test, it's a right-tailed test. Now, if we were asked to finish the hypothesis test, actually conduct the critical value method of hypothesis testing, we would see if the test statistic fell in that critical region. You can see that if this is 0 on a standard normal curve, 1.41 is not quite as far over to the right as 1.65, so it does not fall in the critical region. So it fails the critical value test, and the result of that is that we cannot reject the null hypothesis. We do not have enough evidence to support the claim that P, the proportion P, is greater than 0.8. So this is showing you two of the three methods for conducting hypothesis tests. The p-value method, where we found a p-value, and the critical value method, where we found critical values and then saw if the test statistic lies in that critical region. The third method that you will learn in this unit is the confidence interval method.